First one is the proximal convoluted tubule right here. So what we have here is your book's example, and it's a good reference, but I don't think this is a really good image to study off from. Why? Because there's a lot going on here. So I'll give you the main points. Again, this is why nephrologists, they're geniuses. Why? Because they understand all of this, and it's a lot to take in the first time you see it. Even like for med students, this is often the gnarliest part of their nephrology unit in their medical education. So what we have here is a cross section of the proximal convoluted tubule. Say you just cut it and look at it from the inside of the tube. What you see are cuboidal cells, but not just cuboidal cells, microvilli. So remember those microvilli, where else do you have microvilli? You also have microvilli in your intestines, right? And what's the purpose of microvilli? Remember, there are all these little projections, they're little fingers. They help your intestinal lumen to catch all these nutrients that you're trying to absorb in your digestive system. So in the nephron, you have microvilli, and this is like a dead giveaway as to what they're trying to do. They're trying to increase the surface area to absorb more nutrients and this was a dead giveaway of what the primary purpose of the PCT is. So reabsorption. Microvilli are there to increase surface area to increase absorption. So the proximal convoluted tubule is where you reabsorb a lot of things like water, ions, but especially nutrients. So just like how your intestinal microvilli absorb nutrients, so do the microvilli in the proximal convoluted tubule. It's there because, again, if you things like glucose, amino acids, and vitamins, if they filtered out and you didn't have the microvilli and you didn't reabsorb them, every time you urinate, you're losing nutrients, you're losing calories. So you'd have to pretty much like eat constantly to replenish all the nutrients that should be in your blood. So your PCT, this is why I like to think of it. The PCT wastes no time in reabsorbing nutrients. Again, why? It's closer right here to where it's actually filtering. If it didn't reabsorb it, all these nutrients would be lost to the rest of the nephron and into your urine. So again, the PCT wastes no time. It also reabsorbs bicarbonate or protons depending on your blood pH. Again, if you have an acidic blood pH, if you're having acidosis, you might want to reabsorb bicarbonate. If you have a very alkaline blood pH, then you might want to reabsorb protons. Okay, so this is an example I like to use. So pretend this is your nephron. Again, your nephron does loop more than this, but this is the biggest, most torturous, the most convoluted river I could find. Say you're camping here and you drop your phone. Are you just going to, okay, oh no, I lost my phone, and wait for your phone to travel all the way down the river and then wait at the mouth of the river to finally collect your phone? No, right? You're probably going to say like, oh my God, I don't have my GPS. How the hell am I going to get home? So when you drop your phone and it's starting to float its way down the river, then you want to catch it as soon as possible, right? Why? Because your phone is valuable. Same with the things like glucose, amino acids, vitamins, and nutrients. Your proximal convoluted tubule tries to catch those to prevent them from being lost further down in the urine production process. So this is why I say the PCT wastes no time. It tries to reabsorb the valuable stuff and doesn't wait until further on into the nephron loop and the distal convoluted tubule to let those nutrients flow all the way and grab it at the last minute. Right? So the thing about the PCT, it also secretes. So this is different from filtration. So what we have is now, instead of things just being pushed due to pressure from the inside of the glomerulus to the capsule, now we're talking about actually taking chemicals and actively dumping them into the filtrate and fluid inside the renal tubules. So it can dump, if your blood is acidic, then you have acidosis, then it's going to dump protons. It also dumps metabolic waste as well, so things like ammonium, remember the protein metabolism, uric acid, creatinine, and xenobiotics and drug metabolites. So it not only reabsorbs the thing you need, like nutrients and ions, it also gets rid of excess and also gets rid of things that are foreign to your body or waste products. So again, filtration, reabsorption, and secretion. Three main functions of the nephron. Filtration, pretty much exclusive to the renal corpuscle. So it keeps cells and large molecules like proteins in your blood. but it filters out small molecules. Reabsorption. The proximal convoluted tubule reabsorbs water, but also things that are valuable to keep in your blood, such as nutrients and vitamins. So the filtration is very crude. It's not very selective. So reabsorption is trying to reabsorb the good stuff your body needs so you don't lose it every time you urinate. Now secretion is getting rid of the stuff you don't want in your body. So things like drug metabolites or uric acid or urea or ammonia. This is where you also dump some of those waste products.